looking at target 1.9, maximum limiting objective, I can calculate the volume of composite figures by identifying the basic shapes to apply the correct formula. So our composite figure, what does that mean? A composite figure is a shape made out of two or more of our basic shapes, right? And those basic shapes, were prisms, cylinders, cones, pyramids, spheres, right? All of those are our basic shapes, okay? So let's look at an example, right? Example 1, find the volume and leave in terms of pi. So here, you see on top, we have that lovely cone. Okay, so I'm going to start by finding the volume of the cone. And if you remember, volume of a cone is 1/3 pi r squared times height. Okay, so 1/3 pi, our radius is 3. It does only go halfway across, and our height is 4. If I multiply this out, I believe I get 12 pi centimeters cubed. Now our other shape that we have here is this cylinder. Okay, so always make sure you're identifying your shapes first. Volume of a cylinder is just pi r squared times height, which is pi 3 squared times 8.5. 9 times 8.5, I don't know if I know that. Sorry, 9 is from 3 squared. Doing some things in my head. And we get 76.5 pi centimeters cubed. Alright, now these two shapes are being stacked on top of each other to find our total volume. Right, since they're being stacked on top, we need to add them. So it's 12 pi plus 76.5 pi. These both have a pi in them, so we can add those together. And we get 88.5 pi centimeters cubed. Okay. So again, we're adding because these are being stacked on top of each other. Right? And we'll look at a different example where maybe we don't add. In example 2, right? Example 2 says a cylindrical tube is removed from a prism. How much volume of the prism is left? Okay? So we'll start with this lovely prism. And this prism is following that Cavalieri's principle. We talked about that briefly. And remember, we said if it's slanted, it's still the same thing. So we have a prism. Volume equals length times width times height. Let's make that a curvy L. So we have 25, 30, and 25. Wrong thing. We get 18,750. Centimeters cubed. So this one has no pi, right? Then, if we look here, we have that cylinder, right? So the cylinder, volume equals pi r squared times height. Well, our radius is only going to be half of this. Okay, so it's 4 squared. Our height, remember, your height connects the bases. It's this line here. I don't have that, what that distance is in my picture, but I know that this distance is 30, and if you look, it's the same distance, right? It's going from one edge of the prism to the other. So our height here is 30. So we have 4 squared times 30. We get 480 have to do our total. Then for our total, I am taking my prism, at 18,750, and removing my cylinder. So removing is subtraction, because I'm taking it out of the middle. So then, we have, if I was asking you for an exact answer, this would be it. This one doesn't have a pi, this one does. I can't actually do anything with them. This is your exact answer. Okay. However, it's asking us to round, right? So we're going to approximate by typing it in our calculator. Sorry, I keep opening the wrong thing. 18,750 minus 480. Pi is over here next to h. Okay. My slope seems off. Slope. Let's try that again. There it goes. If you're getting this on your calculator and not getting decimals, let me know. It's probably just a weird setting. Okay, so we have approximately going around to the nearest hundredth. So 17,242.04. Okay, so if it's asking you to round, make sure you type it in your that pi in your calculator to get a rounded answer. All right, let's look at our next page. What is the approximate volume of the lunchbox shown below? Well, I have this prism on the bottom, right? So the prism is volume equals width times height, which is 10 times 6 times 6, which is 360 inches cubed. So then we have this cylinder, and if you look, this is not a full circle, that's half a circle. So you want to do half of a cylinder. Okay, so if those things are cut in half, the actual circle part is cut in half. All right, we'll do half of the cylinder. So our volume equals the volume of a cylinder, but half of it. Right? So then I'm going to multiply everything I get by 1/2. And then we get 3 squared. Right, this is half a circle because the circle is cut in half. That is 3 squared. And then same thing, our height, the space between the two circles, is the same as this space here. So that height is 10. Okay. And then again, I'm doing 1/2 times 3 squared times 10. Again, if you need a calculator, feel free. But that's 45 pi. Okay. So again, these two things are being stacked on top. It's this and then this on top. So we're adding them together. So I have 360 plus 45 pi. Again, this is our exact answer because we can't combine those. But again, we want to round to the nearest cubic inch. So in my calculator, sorry, they're both red down there. I can't click the right one. 360 plus 45 pi is 501.3. So for the nearest inch, we'll say 501 inches cubed. All right, example 4. Tanya uses a cube-shaped bead with side lengths measuring 12. Stop, let's draw it. Here's my cube bead. Lovely picture there. It's got some dotted lines going there. Perfect, I think a perfect drawing of a cube. And Since it's a cube, it means all side lengths are 12, right? A cube is like a square. It has all the same measurements. Each bead has a circular hole in the middle. Okay. Here's my circular hole. Here's that circular hole on the other side. And they get connected. That's beautiful too. And the diameter is 2. So the whole way across is 2 by the volume of the bead. So, the cube. A cube is just like a prism, right? So it's 12 times 12 times 12. I can't do that in my head. I clicked the wrong one again. And we get 1,728 millimeters cubed. Right? And then we have this cylinder that's cutting through it, right? That's an E. The volume of a cylinder is pi r squared times height. This is a whole cylinder. It's not being cut in half or anything. It's a whole one. So we just do the whole thing. Okay, there's no half in this one. Our radius, again, this was the whole distance. So if we wanted to just, whoops, hold on, a piece of that distance, right, we cut 2 in half. This piece is 1. Okay, so it's 1 squared times, and again, this distance here is the same as this distance here, so it's 12. Well, 1 squared is 1, and 1, I don't know why I changed colors. 1 times 12 is 12. So this is 12 pi millimeters cubed. Then for our total, I'm taking my cube and I'm drilling out this circular hole in it. So I'm subtracting. And this would be our exact answer. They don't have pi's in both. But I want to round it. I can't for the life of me click the right button. 1728 minus 12. And again, pi is down here next to h on this calculator. If you have a different calculator, just quickly ask in class. Okay? And round to the nearest tenth. So that'd be 1690.3. So 1690.3 millimeters cubed. All right, last example. 3 tennis balls are packed in a cylinder. So let's draw our cylinder. And then we'll draw our one. Those are equally sized tennis balls. Okay, our 3 tennis balls. Each ball is 3.3 centimeters in diameter. Okay, so I'm going to draw it going up or over. Right, both of those are 3.3 because diameter can turn any way, right? What is the volume of the empty space in the box? Okay, and everything touches the sides. So let's start with our cylinder. Volume equals pi r squared times height. Okay, well we want this distance here. But we can use the same idea that the tennis balls touch the edges, so space all the way across is 3.3. And if I do 3.3 divided by 2, we get 1.65. Sorry, I don't know why it wants to do that. Okay, so that volume is 1.65 squared. Now our height, I have, right, 3.3, and then this is another 3.3 and another 3.3. So the total height is 9.9, so I'm adding that 3.3 3 times. Okay? And then definitely can't do that in my head. If I clicked the right button. 1.6 squared times 9.9 is 26.275 pi. Yep. Okay, so that's our volume of our cylinder. Now we have to do the sphere, right? Because a ball is a sphere. And volume equals 4/3 pi r cubed. Well, that's 4/3 pi. And just like our cylinder had a radius of 1.65, right? Half of this is also going to be that radius of 1.65. They have the same type of radius. So we have 4 divided by 3 times 1.65 to the third. Right? We get 5.9895. Alright, so it's asking me how much space is left in, right, how much empty space there is in this, like, thing of tennis balls. So, for our total, right, I start with my cylinder, and I'm taking away the space that's taken up by those tennis balls, right? This is the area of one tennis ball. And I have 3, minus 3 of these. Then it is asking me to round the nearest hundredth, so I'm just going to type those straight into my calculator. So I have 26.95275 minus 3 times, pi, minus 5.9895. We get 29 point nearest 100, 1, 2. 29? Yes, 29.12 meters cubed. Okay. All right, and that is it. I'll see you guys tomorrow.